Good morning, good afternoon, everyone. This is Ahmed Sabbah. I am a PhD student in computer science at Birzeit University. I will present my paper named or entitled Android Malware Detection Literature Review. I want to thank my supervisor, Dr. Adel Tawil, and co-supervisor, Dr. Samir Zain. The presentation outline as shown. First, I will introduce some introduction, then Android platform architecture, Android security, Android malware detection techniques and methods, then Android malware analysis that used to detection malware, and finally, I will present a finding and research direction in malware detection and conclusion. The first question we asked, why Android? Android is an open source operating system, and it widely used in the mobile devices and users. It have more than 70% of devices in the worldwide. The number of the application in the Google Play Store, more than 3.3 million application. The number of attack that penetrate the Androids, it's more than iOS. Around 700,000 new malware between early January and June 2021. So the Android is more a goal or a target for the hacker and the malware attack. Now, why this study? What is different this study for other study? This study review the recent paper in malware detection. We defined more than one criteria to study each paper. For each paper, we determine the methods used in malware detection and analysis, static, dynamic, hybrid, or others. We define a new criteria named others. Then we determine the dataset used, a number of malware used for each dataset, for the malware independent application for each experiment. Then what the classifiers or method used to classify or detect the malware, and a result of the best classifier if it use machine learning. Then we define the limitation for each paper. For each paper, we define the limitation. And finally, we define the research direction and highlight the open and challenge issue for malware detection. To know how the attacker penetrates the Android, first we will know how what's the Android platform, and what is the part and component in the Android platform on operating system. Then we will know the component of Android Packet Kits APK is a program run on this operating system. Android platform architecture, it's consisted from 5 layers. First layer called system apps. That's consists the application layer where the user can install and interact with the application. The second layer is called Java API framework that contain a set of components that can be reused to provide a service using API written in the Java language. The second layer, native C++ library. This native library includes Java and C++ library, which are specific to Android development. For example, enable access to content data between apps and apps components. In the same layer, we have other parts called Android runtime. Each app run into own process and with its own instance of Android runtime called ART. Period name before Android version 5, it's called Delvec. The next layer called hardware abstraction layer. In this layer is standard interface that exposes device hardware capability to high-level Java API framework, and the final layers is called kernel layers. This layers contain the hardware devices. It's the lower layer for each request from the user or access the user. It's log as system call to reach in the kernel level in the Linux. Android packet kits. This architecture shown in this slides show the parts and the file for APK file after reverse engineering. This files or this leaves of the architecture consider a resource of the static analysis. For example, Android manifest files that contain metadata information about component of the application, such as security permission, activity and service, and so on. The DIX file that contain all class of Java, maybe in static analysis when we're using API call, we will investigate in the class.text. Now, Android security. Google provide some of the Android security to secure Android operating system. Security mechanism used for Android, it's used sandbox. What does mean sandbox? Sandbox, as figures show, sandbox, Android operating system run the application or each application, its own process isolated with other application. We cannot reach to other application only via a secure inter-process communication protocol. So the communication between app needs a protocol to connect, and each application run in each environment. This security mechanism increase the secure Android application. Second, it's called permission. Permission, it's mean a privilege to access some of part of the Androids. For example, when we need to use content services, we need a permission from the operating system to access these services. Signature means each developer has its unique signature, stamp his application, and next time only the developer have this signature can modify of the application. This methods or mechanism used from the Android operating system to secure its operating system. Now, what is a malware? Malware is malicious software. A mobile malware is gain access to the device for the purpose of stealing data, damaging the device, or anything the user annoying the user. Malware app can be installed in the Android system from official store such as Google Play Store, and third party. We have more than one store exist on the internet. You can install the application from them, and this increase the ability or propriety of the this application may be a malicious application, maybe use social engineering strategy to victim install the application on device. So Android being open source platform, this make its target for the attacker and the hackers. Android mobile malware, virus, backdoor, adware, botnet, Trojan, spyware, keylogworms, and so on, rootkit. This is a type of malware. For each of this type in the literature attack the Android before. Android malware detection. Now, we will talk about malware detection. We classify the Android malware detection to three main methods. The first, it's called network traffic-based method. In the network traffic methods, it's considered as a dynamic analysis method because we monitoring the network traffic during mobile is working, and when we know and during monitoring this traffic, when we see any abnormal behavior for the traffic, this indicate maybe exist a malware or malicious application. Some study monitor this traffic to see if it's contain a sensitive data, such as, for example, if the traffic contain terms IMEI. This indicator that if exists some sensitive data go out from the mobile, that's indicate it exists a malicious application. Inner interaction based and permission based. This two type of malware detection depends on the application itself and the Android vulnerability itself. It means the component interaction between them, and we will clarify more in the next slides. The Android malware analysis. To use any of the detection methods, the objective of the analysis is to extract the features from the Android application. We found three main approach exist in the literature: static, dynamic, and hybrid. And we define another approach called other. That's combined between maybe one of the three approach and add new techniques with them. What is a static approach? Static analysis techniques disassemble and decombine code without require the application to be executed, such as using reverse engineering tools, reverse engineering the APK, and extracted the files and the code exist in this files on this APK, and extract feature from them. For example, manifest file maybe extract the permission requested by the application if it's a request to read the storage and write the storage and Wi-Fi. All combined, this permission indicate is maybe malicious activity in the or this application. It's maybe have a malicious code or malicious software or malicious intent. The techniques used for static analysis: signature-based analysis. This a unique signature pattern for non-malware apps or the antivirus work. For each malware, we have a signature. If the signature the similar other application, it's maybe a malware. Permission-based unnecessary permission request by the application indicate that it may be malicious activity. Resource-based analysis: metadata that describe app component defined in the manifest file, such as intent or permission, may be indicate the malicious activity. Semantic-based analysis: this type of the static analysis use the feature extracted from the source file and then use another technique such as natural language processing. For example, when converting the bind code to the image, and use image classification techniques to classify the image. This we maybe add a new meaning for the features. Or when using the API call that extract from text class.text and deal with this methods and function as sentences with meaning, and use natural language processing to classify or detection the malware. In this paper, this figure show all the resources and combine the resources we can use as a static feature for malware detection. For dynamic approach analysis, we analyzing an application behavior in terms of its dynamic properties. We have two levels of the dynamic approach: hardware level and software level. On hardware level, we monitoring collected data about memory, CPU, battery, sensor, camera, and so on. About software level, the features are extracted from the network traffic, apps, pattern, information flow, privilege, dynamic permission, data access, API call, and system call in the kernel level. For example, as shown in this figure, that trying to steal information such as location or IMEI. This dynamic analysis approach called tint analysis. We determine the source and the sink. So in this network traffic, as we show, it's trying to steal some sensitive information. When we combining two methods, static and dynamic, we can get a hybrid approach. As we shown in this figure, we can extract a static feature and execute and run the APK on the mobile device and extract dynamic feature, then combine together, and after that we using in the detection of malware in this paper use the neural network deep learning. Other approach we defined before or talking before, after extract the feature, we will use new techniques in different meaning. For example, image-based when converting the bytecode exists in the source code of the APK file and convert to image, as we show in figure A. This is a malware image and a benign sample. We can using this feature as a natural language processing techniques. With a natural language processing technique, static and dynamic, maybe in this example, use the static and smelly code extracted, then create a method dictionary and using natural language processing technique to classify the malware and detection. What is of our finding and result? First, as we show in this figure, the static approach is the high methods in the literature. Then dynamic and the hybrid for each paper or for each approach. Each researcher has its advantage and disadvantage for each methods, and each one claim is the static is perfect and other is dynamic is perfect, and this negotiation between them. We will present the advantage or disadvantage for each approach in next slide. Next few slide. Second thing, we will talk a data source or a data set used in the literature. As the figure show, Trippian data set, it's the most used in as a data set have a malware application. For each paper, we determine number of the sample used, malware or benign, and dataset used as shown in the figure. Now we will talking about limitation for each paper. In the paper, we're talking about for each paper what is the limitation in approach, in method, in result, in sample, in dataset, and so on. Now in this slide, we combine the limitation for a set of paper and puts in the one of this maybe challenge limitation for the malware detection. For example, when we're talking about obfuscation, it's techniques to use the code more difficult to understand and analysis. Now, when we're using a static analysis approach, you fall under this type of the limitation. So you maybe not understand the code or not de-obfuscation the code and so on. Dynamic behavior. When using static analysis, malware authors or attacker use more than one techniques to change its behavior or characteristic at runtime. So static analysis maybe not cover this behavior. Encryption. Use encryption to conceal the malware code or other sensitive information. Comprehensive. Some of paper use only permission or use only intent and leave other feature in the static analysis without use in paper. This may be not enough to detect the malware in the static analysis. For the dynamic analysis, the dynamic analysis limitation fall under the first limitation is consume resources. To monitor the application at runtime, you need huge resources to set up the environment if you're using the virtual or the emulator. The instrument used to run the experiment, you need more than tools and you need more than agent. For example, when using Monkey to generate the randomly data or action for the emulator, it's maybe ignore some sensitive action or sensitive data with meaning. So we need more investigation instrument in dynamic analysis. Encryption, for example, when using network traffic and monitoring, this network traffic may be encrypted and maybe evasion the malware from detection. Context, some malware use context aware to do it malicious. For example, the malware hidden behavior until the Bluetooth on or the screen off, or any context appear in the mobile application, real mobile application. It's not exist in the emulator. OS modification, to do some dynamic analysis, you need to root device to log some system call in the Android OS. Now, static and dynamic, each one has a limitations. When combine them, it's maybe increase the accuracy of detection, but we fall under complex model and hard to deploy in reality. Now we will talking about research direction. Malware analysis and machine learning. The machine learning model focus improving machine learning itself and in feature selection. Instead of analysis process itself, we need investigation, more analysis in dynamic and static analysis. Most of the data set label depending on the signature and virus total. We need this if we have a new malware, maybe the signature not exist. So we in the virus total, it's maybe benign apps, and we fall under the zero-day attack. So we need techniques to label a malware in dynamic way or in runtime way in the real device. Virtual environment, not in real. It's not in real device. Most of experiment conducted on the emulator and a virtual machine, not in real device. This maybe ignore some aviation techniques from malware, such as anti-malware and anti-detection. Output model of the machine learning is hard to deploy on real device. So, context-aware detection, machine learning model for real device, auto-update dataset of the malware and its family. Ranking Android malware based on severity and applying new analysis techniques are need more investigation. The second direction is zero-day attack. It's still challenges and the future challenges. Who can discover software vulnerability before attackers or developer? The developing and approach is lightweighted and intelligent enough to monitor application at runtime to detect zero-day attack. It's important, it's difficult, and it's need more investigation in this approach. Malware evasion techniques, we have more than one techniques, large techniques for the evasion techniques, and the new evasion techniques, hard coding, obfuscation, malicious payload, encryption, injection, attack, dynamic code loading, and other techniques for evasion need more investigation. Static analysis may be hard to catch malware, so we need to investigate in dynamic analysis, but it's not cover all execution path. Urgent need to implement hard coding techniques with dynamic analysis approach. So we need to we need a new approach. We need to investigate in the new approach to hybrid and static and dynamic to execute in the real device, maybe on the light model, deploy and monitor the device mobile application. Reverse engineering double-edged sword. So the reverse engineering is important for the security testing and so on, but to found the vulnerability. But at the same time, it's used by the hacker to inject the malicious application in the malicious code in the application, preventing user privacy. Dynamic analysis monitor the application and look the behavior of the app on the mobile device. This may be grants the analyzer to gain some sensitive information, especially dynamic analysis maybe need root of the device. So this type of the analysis need more investigation. Malware detection for iOS maybe it's not in the literature. We not found the enough number of paper analysis and study iOS platform. It's not guarantee 100%. It's a free of vulnerability. iOS need more investigation to study. Conclusion, as we mentioned before, we reviewed static, dynamic, hybrid, and other approach for malware analysis and detection. Now, most of the study focused on enhancing the machine learning model instead of the analysis, lack of research and development method to securing mobile application and detecting their vulnerability early, limited number of study on malware evaluation techniques for cross-platform, specific type malware such as zero-day attack, and those licensed government malware such as Pegasus made investigation some of the type of the malware study in detail. For each paper, we highlighted issue, challenges, and limitation in general for malware detection and analysis approach. I'm finished the presentation. Thank you for listening. Thank you very much.